Hello and welcome to part 19 of the mod making series for locked loot containers. In this one, we are going to be doing kind of a probably really dirty, really short, and really poorly executed kind of lesson initially here, or whatever, little class on binary and bitwise and how binary is used in bitwise operations which we are going to try and use today earlier than I expected for some of the stuff we're going to be coding, the bitwise operations stuff. The reason we're going to be using bitwise operations because of this thing I mentioned yesterday, these enum values with this flags attribute attached to it. These are going to be used as a basically like a binary representation to basically determine what values we want to be allowed and what values we don't want to be allowed. And in this case being the different materials depending on the dungeon type and some other factors. And at least from what I could see, probably one of the easiest ways, potentially, at least the cleanest ways without having like a million lines of code. You know, not literally, but an annoying amount of lines of code and text is going to be using this bitwise operation kind of deal with using binary and such, and do it that way. The first thing I want to explain, at least I really don't want to do this, but because I'm not a teacher, and it's just annoying sometimes trying to explain these like really fundamental things, quote unquote fundamental things that you could probably get you not probably, you could almost 100% get a better explanation from somewhere like Khan Academy or something like that. I'm going to try to explain it in a fairly simple way, and basically just so whoever might be watching, if they've never encountered binary or at least the idea of it, they can at least be like, okay, that's what he's doing when I see those binary numbers on the screen. That's what it's for, and that's what it represents. That's at least what I want to try and do here. So, binary is literally it's just representing something as two possible states, kind of, basically. Like a binary bit is just either a 1 or a 0, an on or an off, an up or a down, a black and a white, a light or a dark, a high or a low. It's just a representation of two opposing states. Not even necessarily having to be two opposing states, but just two states. 0 being one of those states and 1 being the other state. That's essentially what it means. On or off. Like a light switch. On or off. And this gets used in this what is called binary, which is a like our counting system, or whatever you want to say it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and all that. That is a 10-digit number system, whatever you want to call it. It's a 10-digit number system. We represent numbers in a quote-unquote base 10 when we do that. That's how we represent things, generally. But binary is a base 2, which just uses these two values, 1 or 0, on or off. And you could represent any numbers that we do in binary in the same way. You just have to do it in a somewhat more roundabout way, I guess. But the reason you use binary is because that's supposedly, that's what we were told, at least, is that computers communicate this way. Is that they communicate in all ones and zeros. Like, we would write we would write a 3 in our base 10 system as just 3. But the way you would write 3 in binary is actually 1, 1. it means it at the end of the day, it translates to the same thing. It's just a different way of representing it. But with this, the idea of flags is that you could kind of use the on and off state to represent a bunch of values in a kind of more compact way, like true and false. But that's what the flags essentially are, is true and false, and you're able to represent it in a more compact way. Yeah, if you had four flags, you'd have four values you're representing basically. And say if you wanted the first value to be true, you'd say okay, 1. Second value false, okay, 0. Third value false, 0. Fourth value true. There you go. 1001. That's your binary representation of your flags or whatever. Now, the thing that we want to do that is going to be helpful to us here, you could do logical operations due to it being a true and a false thing for each value and an on and an off, is that you could do logical operations, like quote unquote digital binary logical operations with these values, these binary values. Just like if you add not the same thing exactly. Like if you do 3 plus 3, you get 6. You could kind of do the same thing with binary in that you do like, 1 1 plus 1 1 equals like 6, kind of. That's not a great way to represent it, but I think you kind of get the idea there. But really, like with the logical operations thing, is it's mainly what happens, what changes when you quote unquote combine or modify whatever with logical operations to different binary values that represent the same kind of thing generally, and what happens to those values when they're combined in some way. So something like the logical operation of or represented with a this symbol, this thing, that does something different than say and, which is represented by this thing. So the way it kind of works is that you can have let's say you have two binary values that are just a single bit, that being just two numbers each. So if you have a 0 and a 1, and they have two separate values. So if you want to do if you do an or to those two values, like you do an or logical operation, you do this or 1. So what's the end result of that is a 1, because the way that the or logical operator works is that it checks both values being evaluated, and if one of them is true, in this case, if one of them is true, one of them is a 1, then the output of that is going to be a 1. So if instead you do instead in that case, if you do 0 or 0, then the operator is going to be 0, or the outcome is going to be 0. Or if you do 1 equal 1 or 1, that is going to be, the outcome is 1. And this is important because it is very different than and, which works much differently. It works much differently, but in the same sense. So if you do with and, you have to have both values have to evaluate as true, or whatever. They have to evaluate as 1. Otherwise, the outcome is false. Like, the outcome is going to be 0 if they're not both 1. So, if you say do 0 and 1, the outcome is actually 0. Because, unlike or, like I said, it needs to have both values need to evaluate as 1. Otherwise, it's false, 0. So the only way to have these two values in this case evaluate as 1, you have to have both of them being 1. And the same deal if you have 0 and 0, that equals, at least I'm pretty sure that equals 0. That one, I'm honestly kind of feeling dumb with here, but it's something like that. I might be completely wrong with that last one there, but that's the idea. So the way that this kind of works in the end is that you could use this for the more complicated binary values to combine them in some way to do stuff with them. So it's like, in a more realistic example, if you had 4 bits each, 1, 2, 3, 4, and 1, 2, 3, 4. If you had 4 bits each, and you were combining those, let's actually make ones that are somewhat different. Whoops. Not that. Yeah, like that. So if you were evaluating these, 0, that, with a, say, an OR, 0, 0, 1, 0, the outcome in that case would actually be 1, 0, 1, 1. Because it does each individual thing, like this one would be interacting or would be evaluated to that one. The first value, the first bit for each would be evaluated to each other. So it would be 1 and 0, that is a 1 for an OR, and then 0 and 0, that is a 0 for an OR, 1, 1, that's a 1, 1, 0, that's a 1. So that's how that would work. If you did that. And that's what happens in, that's what's actually used in something like the spell system for Daggerfall Unity, is, for the Spellmaker, you have different, allowed targets and allowed elements for each kind of spell. And since you could have 3 different effects for a single spell, if you want to, they have to conform to each other in some way so it doesn't become just completely messed up, like having an effect you shouldn't be able to do cast on self, being able to cast on yourself. It has to kind of they have to conform with each other in some way. And that's what happens here in this Spellmaker window, is that you have allowed targets, and then you have the target flags, which is here. So you either have none, caster only by touch, single target at range, area around caster, area at range. And when you evaluate those in a binary sense, or in like a bit by bit sense like I just did there, you could then use that to kind of filter, I guess you could say, or like have 2 values conform with each other, combine with each other. So like in this case down here for the allowed targets are least permissive results set from combined target flags, which basically means it purposely combines the two to make it so whatever effect of the 3 that are possibly in there, of the 3 that are possibly in that one spell effect, whatever effect has the least permissive target types that it allows, that's what all the others will conform to only allow that. So say if you have a damage spell that has more potential allowed targets than, say, a shield or open spell. So what it will actually only allow, I believe, is say doing target at range, or maybe target on self, or something like that, or Actually, in that case, I think you just would not be allowed to use damage at all, because you can't normally have caster use. You can't normally use a damage spell on yourself. Normally, like you could do an AOE and then that hurts yourself, but you can't do it just straight damage on yourself. You can do something like that in Oblivion, but in Daggerfall you can't. But that would combine these two values with an AND operator. These two these two different binary values for the default allowed targets, which is everything, which counts everything, and whatever allowed targets are in the spell effect that it's evaluating there. And then when it does that AND operation, it'll basically be like, okay, well, if both values aren't conforming to each other, or they're both not 1, then it becomes false. Or then it becomes a 0. So it disallows things from being added, essentially. Whereas the elements one, allowed elements or most permissive results set from combined element flags, is I'm pretty sure it allows multiple elements that you normally wouldn't be able to potentially. Like, I think the allowed elements normally is everything. Or maybe not. I think maybe allowed elements is normally just magic only. Let's see. Yeah, it's normally just magic only. But if there is an effect in this bundle that adds, that allows multiple elements, different elements, then that will be evaluated in a binary operation here to combine them with an OR, which would then be like, okay, so any ones that weren't there, so say if it was 1 0 0 0 for 1 at the start being magic, and then the other one was 1 1 1 1, then both of these combining with each other, the most permissive one would take over essentially and would turn all of those into 1s. So instead of being 1 0 0 0, it would be 1 1 1 1. That being allowing all types of elements. At least I'm pretty sure that's what is going on with this. Like I said, if you want a better explanation, you'd probably be best going to something like like one of those online courses or whatever, Khan Academy kind of thing. But that's the way I've kind of sort of understood what I'm trying to do here, I guess. But let's just, for the sake of it, let's do one for the AND 0 1 and 1 1 1 0. So in this case, the AND operation of these two values would be, let's see, 0 0 1 and 0, because 0 and 1 is 0. Yeah, 0 and 1 is 0. 0 and 1 is 0. 1 and 1 is 1. 1 and 0 is 0. So that would be the end result for ANDing, logical operation of AND, those two binary values. Those two binary values, basically. And this is essentially what we're going to be doing with this in the same way, is that we're going to be setting, for each different type of dungeon, we're going to be setting, how many do I have? I got wood, iron, steel, so 3, 4, 5, 6, 7, 8. Yeah, that's kind of perfect, I guess. 8 bits. So we got like 1, 2, 3, 4, 5, 6, 7, 8. So we got these 8 potential values. And we'll say 1, 2, 3, 4, 5, 6, 7, 8. We'll say that initially all of them are going to be true. You'll be allowed to have every value, or you'll by default you'll be allowed to have every type of chest generate inside of a dungeon type. But we will specify and change those based on what the type is, like how we want to change it. So like, say, in a volcanic cave, we don't want wood, and I'm probably also going to say not iron, because I think iron might be like a lower melting point material than say the others or something like that. So we'll say no wood and no iron. So the end result of that will be something like 0, 0, 1, 1, 1, 1, 1. So you'd be like, okay, so the first two values, wood, and then iron, those two are false, and the rest are true. And then later on, we'll use that to basically say, okay, with that stated, do not allow these types of chests to generate of this material inside of there. Like, we have to, like, it's all well and good if we could just give it these binary values, but the computer or whatever, the system doesn't necessarily know what we're even talking about unless we tell it specifically like what we're doing with those values. So we will have to somehow later on basically say like, okay, so if this is false or if this value is 0 and this is 0 or something, then don't allow those two material types to generate. But if any other ones are true, then allow those types to generate and such and stuff like that. With that, we will also be able to say if we want to, which I thought about was like, it'd be kind of cool just for the, I don't know, the realism, just the little detail of it, is that maybe chests inside of dungeon blocks that happen to have a wet variant, like they have water in them. Maybe those ones that have water in them will be will be more prone to being corroded and in worse condition than ones that are in a dry block. So then we could be like, okay, so these things won't generate or something like that, or in a desert, maybe certain, like, different parameters and stuff. I don't think that'll matter for the material thing in this case, but for other stuff, we might do that. But yeah, for right now, it's just going to be the dungeon types, which is probably not even going to be worrying about combining them, because I'm probably just going to be explicitly defining them inside of it, and then not really being modified by anything else. The permitted materials themselves. Later on, other values might be changed in other ways, but in this case, it's just going to be kind of like, okay, I'm defining myself what values I want to be allowed or disallowed inside these dungeon types and such, inside this context. That's the idea that I'm going to go with for today. Or, well, that's not going to be all I'm doing today, but that's the thing that I wanted to try and explain somewhat to make it a little bit more clear, hopefully, because it might look confusing if I had just have a bunch of like binary values just kind of like strewn about, and then it's like, oh, well, now I have to try and explain it somehow. Even to myself, it might be confusing. I'm like, what the hell was I doing here? So it's good to have this documented, I suppose, even if this is a horrible explanation of binary and stuff like that. But yeah, I'm going to, even though this took way longer than I was expecting it to, this silly explanation, but I don't know, maybe it was useful. I'm going to work on some stuff that I was just talking about, actually do some coding part of it. So I'm going to pause the video, and I will be right back when I've done some of that to explain what I did. So, see you in a moment. Okay, I am back after a stupidly long amount of time. Well, not that long, I guess. Probably at least like 2 hours or something. I don't know. I mean, I did get some stuff done, but I was doing a lot of BSing and daydreaming and stuff. And then I finally was like, you know what? I'm probably gonna go to bed soon, so I'm like, alright, I might as well just record and record the rest of this and explain what I did at least. So, yeah, basically everything was done in the chest generation script today. Main things I added were these three variables here. Not like that necessary, but just kind of useful. Just some constant values, which just means that they basically just means that they're read-only values, but they can't be they're very likely to not ever get changed At least, right now, at least. That's the idea of them. And they just have, like, some things that I would commonly use, I guess, that would make some sense to describe, like, permitted materials underscore none is just permitted materials dot none or whatever. Permitted materials underscore fireproof, which I determined I was like, okay, ones that would be, that would, ones that generate, would not generate inside of places like a dragon's den where, it, one would presume was stuff that is breathing fire, as well as volcanic caverns, which are like very hot and stuff like that, would probably be only chests that are made of materials that are hardy enough, or whatever you want to say, fireproof enough that they wouldn't have issue being inside that kind of environment. So in this case, I was like, all right, so wooden definitely wouldn't be fireproof in my opinion, at least, not most of them. And I said, you know what, let's do iron as well, because maybe iron is like, I don't know, lower melting point than some of the others or something. I don't know. Just two I wanted to take out in that case. So they won't generate in volcanic caverns and dragon's den and such. And then the other one that's used much more is the default, which is permitted materials underscore all, which is just all types can be generated in this case. And then after that I added or whatever, I instantiated a new variable within our on transition interior, add loot chest on transition interior, add loot chest. Let's change that to just add chest on transition dungeon interior, because later the loot is going to be something else, or at least that's going to be generated in a different way. So let's separate those words to make it a little bit more distinct. But yeah, I added this variable here, and its default value is, as I said, permitted all materials. And then in that big case switch statement that I had before, for all the different dungeon types in the game, I added some values to all of them to differentiate each one. And these values are basically what material chests will be allowed to generate in these specific types of dungeons. Now, some of them I could have grouped together, but I know I'm going to add some other values later to the same switch statement, so I was like, you know what, let's just keep them all separate for now, because they're probably all going to be different in some way later anyway. A good few of them, I was like, alright, just do permitted materials all. But then there was ones that I thought made some sense, at least to me, at least. I was like, okay, so in orc strongholds, I don't know, orcs probably wouldn't be using just mundane wooden chests. They'd probably be using only very heavy materials, as well as their own orcish materials in their kind of strongholds, and just one slightly more magic resistant one, but the rest of them are not allowed. In prisons, I was thinking like, okay, well, if it's prison, there's probably not that much to really protect that is like worth stealing, or at least taking, whatever, worth putting in a chest, probably in some kind of prison. So only the most like mundane chests can generate there, that being wood or iron, basically. Desecrated temples, I was like, well, it was a temple at some point that wasn't desecrated, so I don't know. At least some temples, they might not like Daedric material or some shit like that. I don't know. So I was like, all right, temples can have everything but Daedric chests. Mines. I was like, well, maybe mines wouldn't have super magically resistant chests, but they would still have like dwarven potentially. Not super valuable stuff, maybe, because there's people there. But then natural caves, it's kind of contradictory to that, where I have almost everything but Daedric, because it's like, well, somebody in a natural cave might have purposely put to me, it would make more sense for somebody to purposely go into a cave like that to hide something, like a treasure or some shit. So maybe any material almost besides Daedric. Covens, kind of the reverse of the Orcish, where it's like maybe covens where they're more like magically inclined would have their chest that they would allow. Daedric, obviously, as well as mostly the magic resistant chest, but not not really any of the mundane ones besides wooden in this case. And it kind of goes just the same kind of idea through most of these cemeteries. I had similar to prisons where it's only wooden and iron because I'm like, well, a cemetery is the very common dungeons that you could find anywhere, and it's like, well, I don't know. People that are probably gonna bury their dead at a cemetery instead of like a family crypt. Uh, maybe it's not necessarily true. It would be like, well, they're probably not as wealthy, so they might not have as many valuables to actually like, I don't know, hide or at least not high security stuff, expensive stuff to hide them with kind of deal. So I was like, all right, and as well as since they're so easy to access, it's like, well, you could probably use them more as like a training place for your lockpicking sort of deal, but less likely to get like good loot from there and stuff and such. Yeah, that's basically the logic I was kind of trying to go for here, even though some of it might not make too much sense even to me. But that's just what it is for now. Not saying these won't change eventually if there is a good reason to and everything, or somebody convinces me to, or in some way. But now that I have those, at least this specific thing defined for the dungeon types, um, yeah, I was kind of taking a little bit to think like, what should I do next now, uh, in this specifically? And it's like, well, there's definitely more parameters I want to define, but I don't think, I think in this, probably the next things that would be defined, potentially in this, but maybe that'll be even later as well, but I'll have to see. Since I said the order of operations, traps would probably be last, or almost last. Um, but maybe I would put like the limits and sort of trap types that would be more common in these different dungeon types or something like that. That might be, but I'm not. I'm just gonna type out a comment. Maybe the next parameters will be for when I get to defining what traps, mounts, and trap types are allowed / common in some dungeon types. Yeah, I'll just write that down for my own notes there. But that, for this at least, might be the final part for now that I'm going to work on for the, like I said, this specific switch case statement. Because in terms of the types, outside of the loot, which I'm not worried about at this second, that's going to be done later. This, I think I'm good for now, like I said, until I get to possibly traps. But that's not going to be for a while. So the next thing I might try to do after this is possibly even more filtering out of like certain things. Like maybe the actual values that will be sort of defined within those chest materials. Like I know those are going to be slightly different, but maybe the modifiers that will be given to them based on certain context, like I said, with the potentially wet dungeons or dry dungeons or the climate or something like that. Maybe certain values will be different modifiers, so maybe I'll do something, another switch case involving some of that stuff, and with the modifiers or something like that. I don't know. But I'm definitely going to go into more of the finer detail stuff involving the specific parameters and values for the chests that are being generated and their initial main values like sturdiness, magic resistance, lock complexity, jam resistance, all that stuff. So that's probably what I'll do next in the next episode or something. But for right now, I think I'm happy with the this specific thing that I did with the enums and the flags, which I have no idea if this is gonna work like I'm expecting it to, but uh, I'm kind of hoping it will, obviously. So I'll just have to see when it happens. I mean, I guess worst case, I have the stuff, the idea down. So if I have to fix it, how it actually works, like syntactically or in terms of its logic, I should be able to. It just might not be as like this as it is right now. But like I said, I'll have to see. But yeah, in the next one, we will try to determine what exactly we're gonna do next involving the chest generation part. But for right now, it's pretty late, and I think I'm ready to go to bed soon anyway, so thank you very much for watching, and I will see you in the next one.